that do badly at this test is not very good at predicting people's reading skill, basically.
Do you have an example of an optometric test?
I haven't got one up here, and I wouldn't, to be honest, spend your time looking at them, because my personal view is when optometrists try and diagnose an educational problem, they do about as well as when a teacher tries to diagnose an optometric problem. They shouldn't be doing it. We know what we're doing. We don't know what they're doing. You know, we should each respect each other's professional boundaries.
What do you mean by screening test?
Yeah, screening test is a way of trying to get an idea whether somebody has the problem. So, for example, screening tests for breast cancer are mammograms. They screening test for yeah, I'm trying to think of other screening tests. Thank you. Now, I talked earlier about early detection. Everyone knows that early detection is good. The younger you pick up problems, the earlier you can intervene and try and prevent the problems developing. So I talked earlier about rhyming and phonological awareness. Could you do a test of phonological awareness to screen preschool children to pick up those who are likely to go on to develop dyslexia? Now, these are the two leading researchers in this field, and they have done lots of work on this, and the work is ongoing. They've come up with precursors in preschool, trying to come up with early detection. And even these people who research this and have huge studies looking at this, still find that although you can come up with a screening test that will sometimes predict dyslexia, it doesn't get it right in anywhere near enough cases to be acceptable. So early detection is still a goal that has not yet been achieved. How common is dyslexia? Well, if you define it as the bottom end of the distribution of reading, then where you do your cut-off would define how many have the condition. But typical values are between 4 and 8% of children. And these researchers, I spoke about Hume and Snowling, what they show is that most reading tests have a normal distribution. So if you imagine your curve, it will be something like that, your bell-shaped normal distribution curve, and if you say your cutoff is the lower cutoff, then it depends where you take your cutoff. If you say that those who are more than 1.5 standard deviations below the mean are the ones that are bad enough to have dyslexia, then it will be 7% of the population. If you apply a stricter criterion, and you say that those who are more than 2 standard deviations below the mean, as I showed you in the last presentation about that example of K readings, if you say it's more than 2 standard deviations below the mean, it will be the bottom 2.5% of the population. The condition, though, interestingly, is more common in males. Now, there was a big argument about this a few years ago. An American researcher, Shaywitz, said, do we think it's more common in males because parents refer boys with dyslexia, but they don't refer girls? Are the parents being sexist? And they researched it properly, and they showed that that does happen, sadly. Parents are sexist. They worry more about educational underachievement in boys than girls. But even when you do proper research and you don't just look at the people that are referred, even when you go into the schools and test them, you still find that it is more common in males. It does affect more boys than girls. How often is there a visual component to dyslexia? Well, that's where things are most controversial. Some people say that there are never any visual factors in dyslexia. Some people say, some experts say, that 70% of dyslexics have a visual component to their problems. I think it's between 1 in 5 and 1 in 4, in my view, dyslexics, where there is a co-occurring visual problem of one sort or another. So, classification of dyslexia. Here's a model of the reading process. The written word ends up producing, hopefully, comprehension, meaning, and pronunciation. We can say the word. And when we learn to read, there are two pathways that we use for that. The first pathway that children learn when they start learning to read is called their sight vocabulary, just from recognising the shape of simple words. And in England, they typically read books with stories about cat and dog and hat and things like that. They're very simple words, and they have a sight vocabulary where they remember the shape of that word. As they get older and they get to more complex words like helicopter, catastrophe, family, these more complex words require phonological analysis that we spoke about before. The point I want to make is both of these pathways have to start with vision. People often say that this is your visual pathway and this is your auditory pathway, and that is just wrong, because both pathways start with seeing the word. And this is something we often have to make clear when we're dealing with psychologists and teachers. They say, I've got a child and they've got a problem with their sight analysis, but not a problem with their phonetic analysis, so do they need to see you more than one who has a problem here? And I say no. If any child's struggling at school, they need to see an optometrist. So an early classification was by Bode. Bode classified them as dysphonetic and dyseidectic. Sorry about the projector, really doesn't like blue. So dysphonetic and dyseidectic. Dysphonetic are people where their phonological skill is poor and they rely on the visual appearance of words. Dyseidectic are those where their visual sight recognition pathway is not so good, and so they rely on a phonological analysis of words. And Bode also said that there was a mixed category, and that mixed category tended to have the severest deficit. They had both going on. American optometrists, Griffin and Wharton, they used Bode's classification, dysphonetic again, and dyseidectic, but they also said that there was a third category, dysnemkinetic. What a horrible word, eh? But they said this was characterised by excessive letter reversals. And then the dual deficit hypothesis became popular, which was that there's a phonological deficit and this naming speed deficit, and these dual mechanisms were apparent. So the naming speed deficit, people perform poorly at rapid automatized naming, automatic naming. So the sort of task you do here, somebody asked about this earlier, is where you just read this out, SD, APD, OAP, SO, and so on. And you read it out as quickly as you can. And people then said some people have a mixed deficit of both of those. But the problem, and please don't try and write this down, the point of this slide is just to say that the simple reading model that I showed you is such an oversimplification. We don't need to know this, but I'm just telling you and making you aware that there are people out there who study reading and who really think very carefully about the component processes, and it's much more complex than these simple classifications allow us to classify. And this really raises a very interesting question, is this desire that people have had to put dyslexics into classification subtypes, is it valid, actually? People have been doing it for a long time, as we've spoken about already. But Naidu did an interesting research study where she did a cluster analysis. Now, it's a type of statistical analysis where you get a group of people and you measure lots of different variables, lots of different skills in those people. And you get a very powerful computer to work out whether their ability to perform these different tasks, whether their skills in different areas cluster together. In other words, you ask whether people naturally form into groups. And when you do this sort of cluster analysis, you do find that sometimes for some conditions people fall into groups, but other conditions they don't. And Naidu argued that dyslexics don't readily fall into subgroups. She said subgrouping them just doesn't work. Another factor analysis 10 years later also had trouble classifying them and argued that the so-called visual group really weren't a visual group at all. They were a group who had a labelling difficulty. And Brown argued that dyslexia is so heterogeneous, it's so individual, that it really defies classification. In practice, what happens? Well, in practice, when an educational psychologist assesses dyslexia, they try and treat each dyslexic as an individual and assess their individual strengths and weaknesses. So here's a cluster analysis study, and there was a very recent one by King et al. That argued that they do fall into 4 categories: a phonological deficit, a rapid naming deficit, both phonological and rapid naming deficits, and neither of the two, which is about 1 in 5. So there's still a controversy over whether they do fall into subtypes or not. Last topic of this talk, etiology of dyslexia. Is dyslexia just poor reading, or is it a specific condition? So Ratu and Yule were leading researchers on this. Now here's your normal distribution. What Ratu and Yule said is that there is a hump at the tail of the distribution of reading. So here's reading skill. Most people are average, some are very good, some are very poor. They said there is a hump here, a hump of poor readers who are dyslexic. But other researchers then argued against that. Stanovich said there's no hump in the distribution. Beaton said the same thing. Beaton argued, though, that actually it doesn't matter whether there's a hump or not. He did the maths, and he said that to really prove whether there's a hump at the end of the normal distribution, you'd need more than 5,000 participants. This study also found no hump in the normal distribution. This was a graph in their paper. And Hume Snowden also argued for no hump. So there probably isn't a hump at the end of the normal distribution, but nonetheless, there does seem to be a specific condition of dyslexia because of these correlates that we've talked about already. Coding difficulties, particularly the poor phonological awareness. So the phonological deficit theory is the predominant theory now that accounts for dyslexia. For over 30 years, this guy Valentino has been a strong opponent of the idea that dyslexia results from visual problems. And he's argued that disabled readers, most of them, are good at perceiving letters and word symbols accurately, but they mislabel them in oral reading because of difficulty associating symbols with the verbal counterparts. So his argument is their vision perception is okay. Vision is not the cause of their dyslexia, it's this phonological deficit. Other theories have been listed. We mentioned most of them. Here's a complete list of them. But I think it's safe to say that in the 21st century now, really, when you read the big names, the real experts in dyslexia, there is a consensus now that the phonological deficit lies at the heart of dyslexia. And this was summarised in this recent review. which argued that dyslexia is difficulty at the word level, and it's largely down to the deficit in phonological speech processing, and that there were two components to this. The first component we spoke about before, the phonological skills, and the second, the acquisition of print to sound decoding skills. So phonological deficit and decoding deficit. And as we've said, they precede the problem with reading, and they can be characterised in preschool children as worse than average performance at rhyming and naming skills. But I really want to move away from this type of argument about etiology. Let's briefly mention though genetics, because there is evidence for a genetic basis of dyslexia. I told you about my family. My family would suggest a genetic basis, and there's very good evidence for this. There's agreement on this now, that about 2/3 of the individual differences in reading are attributable to genes. About 40% of parents who have offspring with dyslexia, the parents have dyslexic tendencies themselves. So there is a strong genetic component. And we talk, don't we, when we talk about amblyopia, about a sensitive period, there's evidence for a sensitive period for dyslexia, for learning reading as well, between 4 to 7 years. And we talked about male to female ratio, 1.5 to 2 to 1. So it's almost 1.5 to 2 times more common in boys than girls. The biological basis of dyslexia, there's been lots of studies with brain mapping on dyslexia, and as we've said, it's less prevalent in populations with a better constructed language than English. So here's a simplified model, causal model of dyslexia. This guy, whose name I can't pronounce, argued that you start with a genetic predisposition. This affects the brain symmetry and causes a phonological deficit, which lies at the heart of the dyslexic difficulty. The point I want to make, though, goes back further, and this is research in the 1980s by a leading neurologist in America at Harvard, Galaberda. Galaberda dissected the brains of dead dyslexics. And when he dissected these brains, he found some anatomical differences between their brains and the brains of good readers. And he used these anatomical deficits to argue that there may be a cause in terms of genes and maybe testosterone in the womb. And when I first read this study, it made a lot of sense to me. Because remember I quoted Benton before, saying that there are so many things that are correlated with dyslexia. And if we have an underlying etiology like this, where there's some genetically predisposition towards having a slightly different structure of the brain and some very subtle abnormalities of the brain, those could be things that will cause the phonological deficit that underlies dyslexia, but that also cause non-causal correlates of dyslexia. And this really takes us to where I think we need to be right now, which is moving beyond the battle that there was in the 1970s, with some people saying dyslexia is about phonological deficit, it's not about vision. And other researchers saying, but there are visual correlates of dyslexia, and we think they cause the dyslexia. And everyone's been fighting over causes. And I don't think you need to have that fight, because I think we need to look for the correlates of dyslexia and then ask whether those correlates of dyslexia, even if they're not the cause of the dyslexia, may be a contributory factor. And that's where I think we are now. But I think many of the recent visual factors that are associated with dyslexia, things like binocular instability, things I think like visual stress, may not be the cause of the dyslexia, but they are co-occurring factors. And if you treat that visual problem, you won't cure their dyslexia, but you'll take away the visual component of their difficulties. So treatments for dyslexia, there's well-established evidence showing that specialist teaching is the big thing that works in dyslexia. I mentioned this before, that Humans slowly summarised the evidence in a review, and I think they're right, that there are two main types of reading disorder. There's dyslexia, which is a problem with decoding and phonological decoding, so the accuracy is the problem, and there's a comprehension problem, adequacy of understanding text. And they make the point that when the teachers remediate dyslexia, they need to know what the underlying problem is, because dyslexics require interventions to promote decoding, particularly to train their phonological awareness. Whereas people with a reading comprehension problem, they need training in oral language skills. And that's really where we are now with the consensus. And Frick et al., they have done research looking at oral language program, showing that's effective at training reading comprehension. And there's evidence that training phonemic phonological awareness can help in dyslexia. So let's draw some conclusions. Dyslexia is characterised by a phonological deficit. The other main type of reading disability is difficulty with comprehension, and the best validated interventions for dyslexia are educational interventions. Optometrists don't diagnose or treat dyslexia, but I do think we have a role to play in managing co-occurring visual problems. And that's what the rest of this course is all about. Any questions before I go on to the last topic of the day? Okay, well the last topic is the one that is going to be easiest for you, because now you're on home ground. Now we're going to talk about what we optometrists know most about, and this is diagnosing two conditions that may correlate with dyslexia.